It says that after 1960, the economic growth in Switzerland has grown in an exponential fashion. So we're looking at the Swiss GDP per capita and the US dollar. And we are given the function is 1,806 times, and then the growth rate there is 1.037 to the power of t, where t is the number of years. So the first thing that we have to do is to sketch the graph, or to draw the graph. So we're going to do that using our calculator. So we're just going to go to our calculator and type in the function that we were given. So 1,806 multiplied by, and then we have 1.037 all to the power of x. Now on my graph, I may need to change my window. So I should change my window to what we have here, which goes from -40 to 140. So on the x-axis, we have -40 to 140. And then on the y-axis, we don't have any negative, and it goes all the way up to 100,000. So I'm actually going to leave it at -5 so that I see the axis, and it goes up to 100,000. And it looks something like this. So you can see in the scale of what we're looking at, it crosses really low down. We know an exponential function comes across like this and then increases exponentially higher. Now we need to find where does it cross the axis if we're going to sketch it. So we're finding the value when x is 0, and it crosses at 1,806. So the first thing that we're going to do is just label that onto the diagram. So 1,806, which is really low down, somewhere around here, and it's just a general impression. So 1,806, and I'm actually going to write the full number because that's the exact form. And I then need to just show roughly the shape. So it looks like it ends somewhere around here. So we're just going to come across and show that exponential pattern. Now we should not have anything in the negative x, because if this is looking at GDP and time, we cannot have a negative time. So this part of the graph should not be there. Okay. And for the second part, it says to write down the GDP in 1960. So that's when it first started. We were told at the beginning of the question that it's after 1960, and that t is the number of years after 1960. So this is essentially asking for when t is equal to 0, and we actually already found that. It's our axis intercept, so it's 1,806 US dollars. And then for the second part, it asks us for the GDP in 1961. So that's when x is 1. So again, I can just find the value when x is 1, and it's 1,872.80. So 1,872.80. Now we should always leave any numerical money value, any money or currency, to 2 decimal places. And the next part is to find the year in which the GDP per capita reaches over 100,000. So now I can plot on my graph 100,000. And we're going to find this intersection. So second function trace, we go down to the intersection. Let's go a little bit closer to where we want to find it. And we can see there that it's at 110.48 years. So 110.48. Now, at 110 years, it won't quite be there. So that means that we have to round up to 100, because it's asked for the nearest year, to 111 years, which means that it's actually 2071, because it's the original 1960 plus 111 years. Now, in terms of our working out, you could show that either by drawing this, which is at 100,000, and then showing that intersection. Or you could draw it on here and you could show that you have tried to find that value. Or you can say that it's when 100,000 is equal to the original function, which is 1806 times by 1.037 to the power of t. Any of those methods would be fine, so you'd get the method mark. Because if you do go wrong in a question, you always need to have those method marks. So the marks for this question, the first one of them is for the shape. Now that shape includes the domain, which means that you can't have that negative section drawn. And there is 1 mark for labeling on your y-axis. There is 1 mark for finding and stating the first initial value. And then we have 1 mark for finding and substituting when x is 1. And then 4 marks at the end there. 1 of them is for the final answer. 1 of them is for finding this answer here, and then also a 2nd mark for realizing that you needed to round up. And 1 mark is for the method, which could be drawn in any way. So if you did this in your head, or you did it on your calculator, but you didn't show any working, and then you got a different value, or even if you got the same value here, but you rounded it down to 110, if you only put your answer as 2070, you would get no marks. But if you had written this and you had shown some working, you would have got 2 of the 4 marks, even if this and this were wrong. So it's really important to show your working there.